Hi, Rich Maltzman here in my secret mad scientist library slash laboratory. And what I'm going to do for you now is walk you through the creation of a network diagram, a project network diagram, and the means in which you can calculate the critical path. And to do that, to do a forward and backward pass through the network. All of these network diagrams start with a simple table, as you see here. And on that table, you'll see three columns: the name of the task, which we've abbreviated here, the duration of the task, in days in this case, and the predecessors. So let's take those one at a time. The task name, some of the tasks have zero duration. In this case, very simply, start and end have zero duration because they're milestones. They're important dates that help us anchor the schedule. So start and end are examples of milestones. So would the end of the third quarter, or providing a key deliverable to a customer by a certain date, or having an audit completed by a certain date, those would be milestones. They don't take any time in and of themselves, but they are very important to your project. So you'll see that the duration for start and end, 0. They'll be represented in the diagram with a diamond. Diamonds represent milestones typically in network diagrams. Tasks are typically shown as bars with the length of the bar indicating the length of the task commensurately. So here we have A, B, C, D, and E, pretty boring names for tasks, and their durations of 6 days for A, 4 days for B, 7 days for C, and so forth. You can see in the duration column. The predecessor column is really where the logic of the diagram is shown. And if you look, for example, at task C, we're saying, yeah, it has a 7-day duration, but it can't start until both tasks A and B are complete. We're using a finish-start relationship for this network diagram, meaning that we have to have a task finish before the next one starts. There are other relationships like start, and finish, start, and start, finish, but we're going to focus on the most common, probably what will be used in the exam only, which is a finish start relationship. An example: I can't start to frost a cake until I've finished baking it. If you've ever tried to frost a baking cake, it doesn't work. So we're talking about a finish-start relationship. And here, for example, task C cannot start until both A and B are finished. Also of note, I'll be using what's called the one method, which means I'm going to start at the morning of day one in my calculations. And I'm going to use a lot of visuals to help here because this just doesn't work with a lot of hand waving. Okay. So let's move ahead into our network diagram. We've taken the information from that table and created a network using arrows, and arrows are key. Arrows to communicate visually those dependencies based on the predecessors. And if you remember, C cannot start until A and B are done. That's represented by these two arrows. Task C cannot start until both A and B are finished. That's called a merge. That particular configuration is called a merge because several arrows come in together. A burst is when more than one arrow comes from a task. So B has a burst coming from it. As you see, task B has two dependents. C and D both depend on task B. Okay, so that is our network diagram. Now let's talk about how we can calculate something called a critical path, which is the shortest time in which the network can be done. And one of the things I like to make sure people are aware of is that critical means time critical, not importance. Every task on this network is important, or it wouldn't be on there. Every task in this network comes from the WBS, which we've all identified as all being necessary. So it's not about importance or ranking, it's about time criticality. So we let our network build. We have the arrows showing the relationships between them, and we will use First, a quick walkthrough to calculate the critical path without doing a forward and backward pass. And there's a shortcut to calculating a critical path by just walking through all possible combinations. So this yellow path, ACE end, has a duration of 18. How did I get that? 6 plus 7 is 13, plus 5 is 18. So that task, ACE, has a duration of 18 days. This next task, the kind of powder blue task, is tasks B, C, and E, and it has a duration of 16. Again, how did I get that? 4 plus 7 plus 5, 16. The magenta path is the final path through this network, BDE, and if I add up those numbers, trust me, it comes out to 17. The longest path through that network is 18. And here's the mind-blowing fact. The longest path through a network lets you know the shortest time in which the project can be done. I'll say that one more time. The longest path through the network indicates the shortest time in which the project can be done and is the critical path. Can you have multiple critical paths? Yes, if you have a tie, you have multiple critical paths. What does that mean? Multiple critical paths, try saying that 5 times fast, indicates that you have more risk because now more tasks become critical. I like to say time critical. So we have not done a forward or backward pass. What we've done is a shortcut to determine the critical path. So on the exam, if you are asked to calculate the critical path, you don't have to do a forward and backward pass. You can do this walkthrough method to find the critical path. In this case, ACE is the critical path. We usually highlight that with red or bold or in some way indicate that ACE is the critical path. Again, what that means is if anything on that critical path slips in time, it takes longer than we expected, the overall end date will be pushed out. Now, here's an interesting thing to think about. What happens if one of the tasks on the non-critical paths expands greatly? Well, think about it. It could then become the critical path. And one of the things that you should remember about the critical path is that in a real project, it's dynamic. The critical path could change. Certainly, it's going to be a more complicated network diagram. Certainly, there's going to be more risks and contractors and subcontractors not performing. So that critical path will shift, perhaps daily, depending on the type of project you're working. All right, so let's do this calculation. It starts with a key, and the key is shown in the lower right here, the southeast corner, and it's showing you the early start, or ES, the duration, how long the task is in the top center, early finish in the top right, late start in the lower left, late finish in the lower right, and float or slack, which are synonyms, in the center bottom. So same exact information, but we're going to put it in this keys format. So we start by simply putting the durations at the top center of each of the tasks. No magic yet. All I've done is put the tasks in the format of the key. Now we start counting on day 1. So here's day number 1. We have a 6-day task. I will count with my fingers because it's really the only way I can count. 1, 2, 3, 4, 5, 6. So that's the end of day 6, and that's when task A is done. We start in the morning of day 1. We have 6 full days. We end in the evening of day 6. I'll let that sink in for a moment, and that's the beginning of a forward pass. Now we start on day 7. Because this is the evening of day 6, I have to go home and sleep. The alarm clock wakes up on the next day. And on the morning of day 7, I start task C, or whoever's doing task C starts task C. And we have 7, 8, 9, 10, 11, 12, 13, 7 days. So that's going to be a 13. Now, note that there's another arrow pointing here that tells me this number could change. On the forward pass, and I'm going to use a little bit of annotation here if this works out right. On the forward pass, you look at the 2 inputs and notice that's kind of like a greater than sign. We always take the larger of the 2 inputs. So if this turns out to be 23, I'm going to have to put 24 here. Okay, good. So just note that when you have multiple inputs, we have to consider the other input. But for now, that's a 7. That's 13. So does anyone want to guess what's going to show up here? Probably a 14. This is the evening of the 13th day. And there's the 14th day, the morning of the 14th day. Again, I may have to change that because task D may have a later date. The larger of the two tasks on the forward pass gives you the date that you put in here, the day that you go there. So here's 5-day task, 14, 15, 16, 17, 18. 18 shows up here. Let's do the bottom row here. Task B starts at day 1. It's a 4-day task, 1, 2, 3, 4. 4 shows up here. Oh, and whew, this is a smaller number. Remember, you take the larger of the two. The larger is 6. This stays as a 7. This is a 4. Anyone want to guess what goes here? You're right. It's a 5. Evening of the 4th day, morning of the 5th day. I have an 8-day task for D. 5, 6, 7, 8, 9, 10, 11, 12. 12 shows up here. I take the higher of these two. Luckily, I don't have to change this. That's our forward pass. When we do the backward pass, all we do is we turn on our secret ray gun that you have in the corner here, and you turn the clock backwards. You reverse time. You start at day 18 and work backwards. So we're going to put an 18 here and count down 5 days. 18, and it's all of 18 because I have the evening all the way through the morning. Remember, we're going backwards. 18, 17, 16, 15, 14. So a 14 shows up here. We count backwards. So this is the morning of day 4. This is the evening of day 13. Counting backwards, that will be a 13. And we count down 7 days from 13, 13, 12, 11, 10, 9, 8, 7. A 7 shows up here. That 7 means a 6 shows up here. And we count backwards, 6, 5, 4, 3, 2, 1. And a 1 shows up here. Nothing too exciting. And actually, this is our critical path. We would expect that the forward and backward pass yield the same. In fact, this missing tooth here is going to be our float. And a little spoiler alert, it's going to show us that that's going to be a 0 for our critical path. That makes sense. The critical path has no room to wiggle. It has no float. It has no slack. Let's do the bottom here. 14, this is going to be a 13. We count backwards 8 days. This is tough for me. 13, 12, 11, 10, 9, 8, 7, 6. 6 shows up here. This 6 is going to yield a 5 here. Oh, by the way, I've got a merge. Going backwards, I have a merge here. So I've got a 6 and I've got a 7. In the reverse direction, I'm going to change to red. In the reverse direction, I have a less than sign. Pretty close. A less than sign. A less than sign means I take the smaller of the two. So not 7, but 6. So what's going to show up here? Anyone want to guess? This is the morning of day 6. This is going to be the evening of day 5. And I count down 4 days. 5, 4, 3, 2, and a 2 will show up here. This missing tooth is your float, and you calculate it by subtracting either of the corner numbers. So 6 minus 6, 0. 1 minus 1 is 0. Let's do that. So we have 18 minus 18 or 14 minus 14. You can check your math, is 0. 13 minus 13 minus 12 is 1. 5 minus 4 is 1, so it's 2 minus 1. 13 minus 13 is 0. 6 minus 6 is 0. 1 minus 1 is 0, 0, 0, 0, 0. That is your critical path. We already determined that with our shortcut. Now we have done the forward and backward pass. Not only do we confirm that ACE is the critical path, we also know where there's float. And the float lives on tasks B and D. Task B and D both have 1 day of float, extra time. Now, how can we apply this? And what might some of the test questions ask you? They might say something like, well, you're under pressure to get this project done earlier. What might you do to get the project done earlier and get to that end date before the 18th day? Now, if you make these people, let's say this is Angela, Charlene, Edward, Barbara, and Diane. And I won't remember the names, but let's say this is electrical work in a home. And let's say this is the plumbing work. If B and D, I think it was Barbara and Diane, are plumbers, and they have some electrical training, you could move Barbara over to Angela and have her help Angela. If all goes well with Barbara helping, this task could be brought in earlier. Now, something to think about. In the real world, does it work like that? Or might Angela feel challenged by Barbara? Might Angela realize, oh no, now I have to train Barbara, and actually it could actually cause more of a learning curve and a slowing down. But in the ideal world, that's one way you could bring this project in earlier. And that's one of the things that a network diagram can show you, is where you have this float and you may be able to use your resources differently. So let's review the critical path. And by the way, a path is one of these paths, like A, C, E is a path. The whole thing is a diagram. B, D, E is a path. B, C, E is a path. Okay. In the critical path method, the network paths that have the least slack, that have a 0 typically, are the critical tasks, and that's the critical path. It's the longest path through the network. Again, they're critical from a time perspective, and it's possible to have more than one critical path especially on a large project. And what that does is it introduces more risk, because now you have a greater number of tasks, which, if they slip at all, causes your whole project to slip. So I hope that's been helpful. That is the quick walkthrough of a forward and backward path, a forward and backward pass in a network diagram. And now I am going to return to my laboratory and work on my PMP passing robot. Thanks, everyone. Take care. Bye.